Engineering Design Summary. Engineering design refers to design principles and processes used by engineers and other scientists aimed at solving problems. While engineering is complex and this is a flexible process, the image on the right identifies the basic structure of the process. So we identify the problem. What is the challenge? What are the limits? How can you solve it? Then we explore. So find out what others have done, gather materials and play with them. Design. So think up lots of ideas, pick one and make a plan, make a drawing or a model. Create. Use your plan to build your idea. Try it out, test your idea, and then finally make it better. Think about how your design could be improved. Modify your design and try again. And then you can see once you're at the try again, you go back to design and then around the loop again. The process shown on the last page can be used to solve many kinds of problems, including developing vaccines or treatments for a new disease, designing new systems for wastewater treatment, testing methods to increase yield of crops, determining how to manufacture an item on a mass scale, or planning the best way to mitigate excessive greenhouse gases in the atmosphere. Identify the problem. The first step in solving a problem is identifying the problem, i.e., what is the problem you're trying to solve. In doing this, it's critical to determine the success criteria. How will you know the problem has been solved? And to identify constraints that will be working against you. Clearly identify the problem, determining what parts of the problem you can solve and what can't be solved, and how to evaluate the problem has been adequately solved will ensure that all stakeholders are working toward the same endpoint. Once the problem has clearly been defined, it's time to do research to see if others' work can be used to help solve the problem. This is the explore step. This step might include reviewing research articles, talking to colleagues or others who've done similar work, and identifying existing similar technology that could be used as a springboard to solve the new problem. Innovations in one area of science and technology often drive innovation in other areas. Design. Teams typically collaborate to design a potential solution to the problem. This part of the process may rely on technical drawings, blueprints, flowcharts, budgets, among other things. Team members will try to anticipate problems that might occur so that they can account for them in their plans. It's much easier and less costly to design with potential problems in mind rather than address problems as they occur. When designing solutions, teams must continue to hone in on designs that will meet the success criteria determined in earlier steps. Create. Once a design has been agreed upon, it's time to build a prototype or jump directly into a first iteration. This prototype or first iteration gives a starting point from which to work on refinement. Try it out. During this stage, teams look for ways to improve the design or maximize the output. These trials lead to systematic modifications and improvements to the design. Even if early iterations prove promising or work, adjustments can still be made to improve performance and ensure that the success criteria identified earlier in the process are met. Make it better. Here, teams implement ideas for improvement. It's important to note that this process isn't always linear. Sometimes there are multiple iterations to identify and implement ideas for improvement.